Hi everyone, in this video we continue our examination of the unit circle and we work through an example involving the unit circle. So here we're told for the angle drawn to the left, determine the reference angle to the nearest degree. Now recall how the reference angle is actually defined. The reference angle is defined as the angle drawn between the terminal arm and the x-axis. So that would be this angle here. So this angle we label as phi, and we said that phi is the reference angle. So here it wants us to determine the reference angle to the nearest degree, and we're actually asked to figure out what this reference angle is, like what is the value of this reference angle. So to do so, let's use our, notice that here we have a acute right angle triangle. If we draw a line from the coordinate that we're given down to the x-axis, this makes an acute right angle triangle. And so now that we know what this distance is, because this distance is just the this distance would be 0.8. This distance here, the magnitude of this distance, or distances are always magnitudes of numbers. So this distance would be 0.6. So, and since this is a unit circle, the radius is 1. I've just drawn it that way. So I can just use the regular acute triangle trig ratios, and I know that sine of the angle phi is equal to it's going to be equal to the x value the y value, because it's the unit circle. It's just the opposite, which is the y value here, divided by the hypotenuse, and the hypotenuse is 1, so we've got y over 1, which is just y. So the sine of phi is going to be just equal to y. Well, let's say it's y over r, because that's how it's actually okay, let's write it as the sine of theta is equal to 0.8 over 1. So here it's just equal to 0.8. And if we wanted to write it out, the sine, cosine, or the for the reference angle, the cosine of theta is equivalent to the magnitude of the x value divided by the radius. The sine, this is the reference angle. We actually use phi, right? So the cosine of phi is the absolute value of x over r. The sine of phi is equal to the absolute value of y over r, and the tangent of phi is equal to the absolute value of y over the absolute value of x. Because no matter where we draw the terminal arm, when we deal with the reference angle, we're always going to be dealing with acute right angle triangles. And so when we take the absolute value of all these coordinates, we just get we just get distances which are positive. So the sine of phi is equal to 0.8 and over the radius, which is just 1. So we get that the sine of phi is equal to 0.8. And since we're only looking for the reference angle to the nearest degree, I can figure out what phi is by taking the arc sine, or the inverse sine, of both sides of this equation. And we get that phi is equal to the inverse sine of 0.8. So phi is equal to inverse sine of 0.8. You can try this out on your calculator, and I encourage you to do so, just so you get comfortable using your calculator, because every calculator is different. So you get that the inverse sine of 0.8 is 53 degrees when you round to the nearest degree. It's 53.13, but that rounds to 53 degrees. So this angle here is 53. Let's erase this, and now we can label it with its actual value. So this angle here rounds to 53 degrees. And next it says it wants us to determine the angle drawn to the nearest degree. Now the angle drawn is theta. So if this angle is 53 degrees and we're asked to figure out what theta is, remember that if we draw an angle from the initial arm to the to this point here, then or I guess back down to the x-axis, then this angle would be 180 degrees. So theta and 53 degrees should add to 180 degrees. So that means that theta is equal to 180 degrees minus 53 degrees. And so theta is equal to 127 degrees. So we've just figured out what theta is by using the reference angle. So we use the reference angle here. Now, let's figure out, here it says the exact value, it wants us to figure out the exact values of the primary trigonometric ratios. So notice here that we've actually, theta is a rounded value because we've rounded phi, so theta is not an exact value, but it wants us to determine the exact values of the primary trigonometric ratios. So in order to do so, let's first figure out what the cosine of theta is going to be. So the cosine of theta is defined to be the x value divided by the radius of this circle that we draw that's centered about the origin. The radius of the circle, which is the unit circle, is just 1. So cosine of theta is just equivalent to the x value, which is negative 0.6. The sine of theta is going to be just the y value because the radius of this circle is 1. So the sine of theta is just 0.8. And the tangent of theta is the y value divided by the x value. So we get 0.8 over negative 0.6, which we can simplify to what this is going to be negative 4 over 3. We'll look at another example in the next video.